There is a kind of bond in nature that distance does not weaken. It does not fade across a room or a country or the dark between stars. It does not care how far apart the two things are carried. And it is not a feeling, not a metaphor, not a mystery of the old, soft kind. It is measured, in laboratories, to a precision that has left by now almost nowhere to stand and doubt it. Two particles meet. They interact, and then they part. One is carried to the far side of the room. The other is carried to the far side of anything you can measure, the next city, the next continent, the orbit of a distant moon. And when, at last, you ask one of them a question, the other answers. Not a moment later, not after a signal has crossed the space between them. Now, in the same instant, as though the distance were not there at all. This is not a trick of timing, and it is not a flaw in the instruments. It has been checked and checked again by people who badly wanted it not to be true. The answer does not travel across the gap. It is simply already there, on both sides at once, in a way the space between them cannot account for. The two particles behave as though the distance is a detail, as though it is painted on the surface of something, and the something underneath has no distance in it at all. This is the phenomenon that Albert Einstein could not accept. In the 1930s, at the height of his powers, he looked at what his own theory implied, and he recoiled. He called it spooky action at a distance, spukhafte Fernwirkung. The phrase was not a compliment. It was an accusation. Einstein believed the world was made of separate things, each one carrying its own properties, each one minding its own business in its own patch of space. The idea that two particles could stay bound across any distance, that touching one could instantly settle the other, struck him as absurd. He was certain it meant the theory was broken. He spent much of the rest of his life trying to show it. And for 30 years, the question lived in the narrow country between physics and philosophy. It was a quarrel about words. It was untestable. It was the kind of disagreement that brilliant people carry to the grave unresolved, because there is no experiment that could ever settle it. Einstein died in 1955 believing the matter still open. He thought that one day a deeper theory would arrive and give him back the world he trusted, a world of separate things with definite properties, a world that did not depend on anyone looking at it. He was wrong. But it took the universe 60 years to say so, and it needed a particular kind of mind to ask the question in a way the universe could answer. That mind belonged to a quiet Irish physicist named John Bell. He spent his days at the Great Accelerator Laboratory near Geneva, designing machines to smash particles together, and he thought about the foundations of his own science as a kind of private vocation, almost in secret, on evenings and weekends. In 1964, working nearly alone, he did something the founders of the theory had not thought to do. He took Einstein's intuition seriously. He took the belief that the world is local, that the world is real, that things have definite properties before anyone measures them, and he turned it into a number, a limit, a line that the data could not cross if Einstein was right. The line is crossed every time, in every laboratory that has ever looked. This is the heart of it, and it is worth letting it land slowly. The universe is not what Einstein hoped. It is not built from separate things carrying private properties across an indifferent space. Something stranger is true, and the experiments that revealed it are not subtle, not ambiguous, not a matter of taste or interpretation. They asked a precise question. The answer came back the same every time, for 60 years, across continents, with the escape routes closed one by one, until there was nowhere left for the old picture to hide. But here the popular story takes a wrong turn. And it is worth marking the wrong turn now, at the very beginning, because almost everyone takes it. It is often said that this strange bond lets you reach across the galaxy, that you could touch one particle and move another. That information leaps across space, that with the right device or the right state of mind, a message could be sent faster than light. What physics actually says is the opposite. Nothing leaps, nothing travels, no signal passes between the two particles, and no message can ever be sent this way. The mathematics forbids it, completely, and without a single exception. Each side, looked at alone, sees only noise. The bond reveals itself only afterward, slowly, when the two records are carried back together and compared by ordinary means no faster than light. So the bond carries no message. And yet it is real and unbreakable by distance. The truth is stranger than the fantasy, and quieter and harder to hold. The two particles do not reach across the distance to influence one another. They were never two separate things to begin with. This is the part that breaks the ordinary picture, and it asks to be felt rather than rushed. We imagine the world as a collection of objects. Each one sits in its own place. Each one is complete in itself, carrying its qualities like coins in a pocket. Two particles, then, would be two such objects, two sets of properties, two small stories unfolding side by side. The strange bond says that this picture, at the deepest level, is wrong. The entangled pair does not have two stories. It has one. There is a single state that belongs to both of them together and to neither of them alone. To ask about one is to ask about the whole. The distance between them is real in space. It is not real in the state. The state does not live in the gap between the particles. It lives somewhere the gap cannot reach. You have felt the edge of this, without a name for it. Two people who have lived beside each other for 40 years finish one another's silences. Nothing is sent. No word crosses the room that any instrument could catch. And yet they are not quite two. The comparison is loose, and physics is not built on comparisons. But the shape of the thing is there. The bond is not a bridge thrown across a gap. It is the quiet absence of a true gap in the first place. So what is the separation we see? The distance is real. You can measure it in meters, in light years. And yet beneath it lies a single state that the distance does not divide. The separation is on the surface. The unity, if it is even right to call it that, is in the depth. And nothing about the depth shows up when you look at either particle alone. Each one, by itself, looks ordinary, looks separate, looks like a coin in its own pocket. The whole strangeness lives in the relation, and the relation is invisible until you bring the two halves of the world back together and lay them side by side. And here is the older shadow standing behind the new physics. The question Einstein stumbled into, whether the world is truly made of separate things, or whether the separation we live inside is the surface of a depth that does not have separation in it, is not a new question. Physics arrived at it in 1935, with a paper and an argument and 3 names at the top of the page. But it had been arrived at before, 2,000 years earlier, on another continent, by people using a method that could not be more different. Not mathematics, not experiment. The long, disciplined, patient examination of experience itself, sustained across whole lifetimes, in silence, by people who left almost no trace except the texts. They reached a conclusion with the same shape. They said that nothing stands on its own, that separation is real, but not fundamental, that to look closely enough at any single thing is to find that it does not, in the end, hold itself apart from everything else. The languages are different. The methods could not be further apart. Those traditions will come later in this telling, named, dated, read in their own words, in the voices of the people who actually wrote them, not flattened into a slogan and sold back as ancient wisdom. For now, they remain a shadow at the edge of the physics, a reminder that this question is far older than the equations that finally made it sharp, and that the equations did not invent the depth. They only found a new door into it. So there are two roads to the same strange country. One is 60 years of glass and laser light and cold detectors in shielded rooms. The other is 2,000 years of stillness. They begin nowhere near each other. They use nothing in common. And they arrive, by their separate routes, at a reality whose parts will not stay fully apart. The equations came in the 1920s. The paradox came in 1935, the experiment came in 1964, and the answer has been arriving ever since, from a basement in Berkeley, from a laboratory in the suburbs of Paris, from a converted farm building in the Dutch countryside, and at last from the light of quasars at the very edge of the observable universe, light that left its source before the earth had formed, pressed into service to settle a question about the nature of the real. The story of how a philosophical quarrel became the most precisely tested strangeness in all of science begins with three physicists. One of them was the most famous who ever lived. They sat down together and wrote a paper meant to prove that the world was sane, that beneath the unsettling new theory, there had to be a calmer, more ordinary reality, with its separate things and its definite properties, waiting patiently to be found. It did the opposite. The paper appeared in the spring of 1935 in an American physics journal under a question for a title. Can the quantum mechanical description of physical reality be considered complete? 3 men had written it. Einstein, by then the most recognized human being alive, and 2 younger collaborators, Boris Podolsky, who shaped the prose, and Nathan Rosen, who worked the equations. It is remembered now by their 3 initials, E, P, R. And it was meant, as the last words of its own argument made plain, to show that the new physics was unfinished, that beneath the strange theory, there had to be a deeper layer, calm and complete, that no one had yet found. The argument was careful. It did not shout. It built a single trap, one step at a time, and the trap was made of an idea so reasonable that no physicist of the old school could refuse it. The idea was this: if you can know the value of some quantity with certainty, without touching the thing you are measuring in any way at all, then that quantity is real. It is part of the world, sitting there, whether or not anyone looks. They called this an element of reality. It is the most ordinary belief there is. It is the belief that the moon has a position when no one is watching it. And then they sprang the trap. Take 2 particles that have met and interacted and flown apart. Quantum mechanics says they may now share a single joint description, the 2 of them bound into one. Measure a certain property of the near particle, and you can predict, with perfect certainty, the matching property of the far one. You did not touch the far particle. It may be a mile away. By the reasonable idea, that property of the far particle is real, an element of reality, because you predicted it with certainty and disturbed nothing. So far, no trouble. But now comes the turn that Einstein had seen and the others had sharpened. You get to choose which property to measure on the near particle, and depending on your choice, you can predict one of 2 different properties of the far one. Two properties that quantum mechanics says cannot both be real at the same time because the theory will not allow them both a definite value at once. Position and momentum, where it is, how it moves. The theory permits only one to be sharp. But your choice here cannot reach across the distance to change what is real over there. That was the unspoken floor of the whole argument. The world is local. What you do here does not instantly arrange what is true a mile away, and if that floor holds, then both properties of the far particle must have been real all along, both of them, sharp, sitting there, because you could have predicted either one without ever touching it. Quantum mechanics describes only one, so quantum mechanics leaves something out. The theory is incomplete. There is a deeper reality it does not capture. That was the claim. It is worth being precise about what it did and did not establish. It did not prove that hidden variables exist. It did not prove the theory wrong in any prediction. It proved something narrower and sharper, that if the world is local, then the quantum description must be incomplete. Locality and completeness could not both stand. Einstein chose locality. He was certain the missing layer would be found. The reply that mattered most came not from a rival, but from a friend. Erwin Schrödinger, the Austrian physicist whose wave equation sat at the heart of the very theory under attack, read the EPR paper and was shaken into clarity by it. Within months he wrote back, in letters to Einstein and in a paper of his own, and he gave the phenomenon its name. He called it entanglement, Verschränkung in his German, a word for things folded into each other, crossed and interlaced past separating, and he did not treat it as a curiosity at the margin. He wrote that it was not one feature of quantum mechanics among many. It was the feature, the one trait that forced the whole theory to break with the old way of thinking. The same year, in the same mood, he set down the parable of the cat in the box, alive and dead at once, not to charm anyone, but to show how the strangeness, left unchecked, climbs from particles up toward the world we live in. And he saw one consequence so sharply that he gave it its own name. He called it steering. By choosing what to measure on the near particle, the experimenter does not merely learn about the far one, he seems to reach across the distance and steer it, sorting it into one set of possible states or another, depending entirely on a choice made here. Measure one way, and the far particle is steered into this family of conditions. Measure another, and it is steered into that one. The far particle has no say. It is steered from afar by a decision it cannot feel and cannot refuse. Schrödinger found this intolerable, and he said so. He did not think it could be the last word. Like Einstein, he expected the strangeness to dissolve once the theory was understood more deeply. Unlike Einstein, he had named the exact thing that would not dissolve. Schrödinger saw the depth of it more clearly than almost anyone, and it disturbed him until the end of his life. Niels Bohr answered too. Bohr, the Danish physicist, who had built the working philosophy of the new theory and defended it for a decade, published his response in the same journal that autumn, under the very same title EPR had used. His reply was dense. It turned on a single phrase in the EPR argument, the phrase without in any way disturbing the system. Bohr said this phrase hid an ambiguity. There is no mechanical jolt to the far particle, he agreed. Nothing pushes it. But the choice of what to measure here, he argued, sets the very terms by which the far particle can be spoken of at all. It fixes the conditions that define what questions even have answers. The system and the apparatus form one whole that cannot be cut. Many physicists read this and were not satisfied. Some read it and were not sure they had understood it. The disagreement did not resolve. It went quiet, and quiet is what it stayed for nearly 30 years. There were reasons, and not good ones. A famous proof stood in the way. A proof set down by the mathematician John von Neumann in 1932 that no theory of hidden variables could ever reproduce the predictions of quantum mechanics. It was elegant, it was widely believed, and it was wrong, not in its mathematics, but in one of its assumptions, an assumption it had no right to make. A young German mathematician named Grete Hermann found the flaw within a few years and published it. Almost no one listened. The proof kept its authority for a generation, and under its shadow, the question of hidden variables became the kind of question a serious physicist did not ask. It was treated as philosophy. It was treated as a thing that could end a career. The deepest crack in the foundation of the theory was left untouched, not because it was solved, but because looking at it was unfashionable. There is a particular silence around a question that everyone has agreed not to ask. It is not the silence of an answer. It is the silence of a drawer pulled shut. And the drawer, in this case, had something living inside it the whole time. In 1952, David Bohm, the same physicist who would later hand Bell the clean spin version of the puzzle, built a complete working theory of hidden variables. Definite particles, always somewhere, guided through space by a wave that the equations describe. It reproduced every prediction of standard quantum mechanics, exactly. By von Neumann's famous proof, it could not exist. It existed. Anyone paying attention should have seen right then that the proof had a hole in it, that the thing it declared impossible was sitting on the page, fully built. Almost no one drew the conclusion. The proof was too respected. The question was too unfashionable. The man who had built the theory was, by then, a political exile whose work was easy to ignore. The contradiction simply sat there, unremarked, for another decade. The drawer stayed shut over a thing that was quietly alive. The drawer was opened by a man who designed particle accelerators for a living and thought about the foundations of physics on his own time. John Bell, an Irish physicist working at the great laboratory near Geneva, treated these questions as a kind of private devotion, pursued in the margins of his official work. He had the EPR puzzle in a form cleaner than its authors had left it. In 1951, David Bohm had recast the whole argument away from position and momentum and into the language of spin, the simple two-way property of a particle that points either up or down along whatever axis you choose to measure. Two particles born together with opposite spins, flown apart, each measured along an axis chosen at the last moment. The continuous haze of the original was gone. What remained was a clean yes and no, a coin with two faces, a thing an experiment could actually count. It was Bohm's version that made the question testable, and it was Bohm's version that Bell took in hand. In the early 1960s, Bell went back to the old proof, von Neumann's proof, the one that had closed the drawer, and he saw plainly what Hermann had seen decades before. The proof assumed what it set out to forbid. It quietly required the hidden variables to behave in a way no sensible hidden variable would have to. Bell pulled the assumption out, and the proof fell apart in his hands. Hidden variables were not impossible after all. The 30-year prohibition had been resting on nothing, but Bell did something far greater than dismantle an old mistake. He had been studying a hidden variable theory that actually worked, a complete, consistent account built by the physicist David Bohm in 1952 that reproduced every quantum prediction with definite particles guided by a wave. By von Neumann's proof, Bohm's theory should not have been able to exist. It existed. And Bell, looking closely at how it worked, noticed something about it that would change everything. Bohm's theory was violently non-local. The guiding wave felt the whole apparatus at once. A setting on one side reached instantly across to shape the motion on the other. Bell asked the question that no one had thought to ask in quite this way. Was this non-locality a flaw peculiar to Bohm's particular theory? Or was it forced? Forced on any hidden variable theory whatsoever that hoped to match the quantum predictions? In 1964, he answered his own question in a short paper published in an obscure journal that almost folded soon after. He proved that the non-locality was forced. Any theory that kept Einstein's locality, any theory in which what you choose here cannot instantly shape what is real there, must obey a certain limit, a ceiling on how strongly the results on the two sides can be correlated, taken across many runs and many combinations of settings. He wrote the ceiling down as an inequality, a plain mathematical line. And he showed that quantum mechanics predicts correlations that rise straight through it. This was the turn that the previous 30 years had not managed. Einstein and Bohr had argued about words. Bell had found a number. The disagreement that everyone had filed away as philosophy, untestable, a matter of taste, was not untestable at all. It made a prediction. The local world and the quantum world said different things, and the difference could be measured in a laboratory with light and glass and patience. Metaphysics had become an experiment. It is hard to overstate how rare this is. Most of the deepest questions a person can ask have no laboratory. What is real? What is separate? Whether the world is one thing or many. These are the questions that philosophy turns over for millennia without ever reaching a verdict, because there is nothing to measure and no apparatus that could measure it. Bell took one of those questions, a genuine question about the nature of reality, the kind that seems forever beyond the reach of any instrument, and built it a door into the physical world. He made the eternal argument check out a result. That had almost never happened before. It is the quiet miracle at the center of this whole story, easy to miss because the inequality looks so plain on the page. A line of algebra had become a way to ask the universe what it is made of. It is worth sitting with what the inequality actually says, because the mechanism is simpler than its reputation, and the simplicity is where the strangeness lives. Picture the bare structure of it. Two distant stations. At each one, an experimenter receives one particle of an entangled pair and chooses, freely, one of a small handful of measurement settings, an angle to measure along. The result of each measurement is one of two outcomes. Call them yes and no, plus and minus. The experimenters do this over and over, thousands of times, each choosing their settings independently, and afterward they bring the two long columns of results together and ask how often the answers agreed. Now suppose the world is the way Einstein hoped. Each particle carries its answers with it from the start, a full set of instructions, settled at the moment the pair was born, telling it how to respond to every setting it might meet. The two particles are like two travelers who agreed on their answers before parting and have not spoken since. Locality means the traveler on the left cannot adjust to what the traveler on the right is being asked. Under that picture, and only under that picture, the correlations are bounded. No set of pre-agreed instructions, however clever, can make the answers line up across all the combinations of settings better than a certain amount. There is no strategy that wins every round. Push the agreement high for 3 of the comparisons, and the 4th is forced to slip. The instructions cannot cover every case at once. That is the ceiling. In its cleanest form, it is a single number. The combined correlation cannot exceed 2. Quantum mechanics does not respect the ceiling. For the right choice of angles, it predicts a combined correlation as high as 2 times the square root of 2, a little over 2 8/10. There is a name for that exact number, set down later by the mathematician Boris Cyrulson. It is the ceiling of the quantum world, the most correlation even entangled particles can show, as firm a limit on their side as the number 2 is on the local side. And it sits above the line. The entangled particles agree more often, across the full pattern of settings, than any set of prearranged instructions could ever manage. The reason the local picture cannot reach so high is almost arithmetical. Each pre-agreed strategy is a fixed list of answers, and a fixed list can be tuned to make 3 of the 4 comparisons agree strongly. But the very tuning that wins those 3 forces the 4th to disagree. You cannot have all 4. The list is too rigid. The quantum pair has all 4. They are not 2 travelers consulting a shared plan. There is no plan rich enough. Whatever binds them is not a packet of instructions carried out from a common origin. It is something the local picture has no room for. The result will not bend. The ceiling is a theorem. The quantum prediction is a calculation. The gap between them is real and was there to be measured. All that was missing now was the will to measure it, and an apparatus delicate enough to ask the question of the world directly. That apparatus took years to build, and the first version of the question had to be reshaped before any real laboratory could pose it. Bell's inequality, in its original form, assumed a perfection no experiment has. Flawless detectors, ideal particles, no losses. In 1969, 4 physicists, John Clauser, Michael Horn, Abner Shimoni, and Richard Holt, recast it into a form that a working laboratory could actually test, with imperfect instruments and real photons that sometimes slip away undetected. Their version is known by their 4 initials, and it became the template for nearly every test that followed. They also did something quietly bold. They proposed in print that the experiment be done, not contemplated. Done. There is a kind of patience in this part of the story that is easy to pass over. A theorem on paper is one thing. The slow assembly of mirrors and filters and counters in a basement, the months of coaxing an instrument toward the sensitivity that could catch a difference of a fraction of a degree in the angle of polarized light. That is another. The question had waited 30 years for someone to make it sharp. Now it waited a few years more for someone to make it real. The someone was John Clauser, and the detail that gives his part its weight is this. He expected to prove Einstein right. He was not a neutral party hoping for a clean result either way. He believed, quietly, that the local world would survive, that the strangeness was an artifact, and that when the experiment was finally run, the correlations would fall back below the line where common sense lived. In 1972, working with Stuart Friedman at the University of California at Berkeley, he ran it. The method was patient and indirect. They took calcium atoms and lifted them into a particular excited state with light, and then let them fall back down in 2 steps. And in falling, each atom released a pair of photons whose polarizations were locked together, born of a single quantum descent. Those paired photons flew off in opposite directions toward 2 polarizing filters set at chosen angles, with a counter behind each filter to register what came through. The experiment asked over and over, across many settings, when this filter passed its photon, how often did the far filter pass its partner? They varied the angles. They gathered their statistics across days of counting. and the inequality broke. The correlations climbed above the local ceiling, in agreement with quantum mechanics, by a margin many times larger than the wobble of chance, a result that could not be waved away as a fluke of the counting. Clauser checked it for years. He did not like the answer. He had wanted the other one, and the world had told him, through his own carefully built apparatus, that the picture he trusted was wrong. There is something in that worth honoring. A man building with his own hands, in a basement at Berkeley, the very instrument that would refute his own belief, and then reporting honestly what it said. The honesty is the whole of the science. The apparatus does not care what its builder hopes. It answers the question it was asked, and the answer stands whether or not anyone in the room wanted it. But the result was not yet decisive, and Clauser was the first to say so. The experiment had gaps. The detectors caught only a small fraction of the photons, which left room, narrow but real, for a defender of the local world to argue that the unseen majority behaved differently from the seen few. And the polarizer angles were set in advance and held still, which left another gap. In principle, slow as it was, some influence could have crept from one side to the other during the long moments while the settings sat fixed. These were not desperate objections. They were honest holes. A theorem this consequential deserved to be cornered with no holes left at all. The cornering began in earnest a decade later in a town outside Paris. Alain Aspect, working at the Institut d'Optique in Orsay in 1982, set out to close the most troubling of the gaps. The worry that the two sides might somehow be in communication while the settings held still. His answer was to refuse the settings any chance to stay still. The two wings of his experiment stood about 13 meters apart, far enough that light itself, the fastest messenger there is, needed some 40 billionths of a second to cross between them. So he built switches that flipped the orientation of the analyzers faster than that, redirecting each photon toward one setting or another every 10 billionths of a second or so, changing the question being asked on each side, while the photons were already in flight and long after they had left their common source. The choice on the left was made too late and too fast for any word of it to reach the right before the right had already answered. Each side was asked a question that the other side could not possibly have known. The correlations still broke the ceiling. They still matched quantum mechanics. Whatever bound the photons was not a message passing between them, while the analyzers sat waiting, because the analyzers no longer sat waiting. Aspect had shut a door that Einstein's defenders had hoped to keep open, and the result walked straight through where the door had been. Picture it for a moment in plain terms. Two switches, far apart, flipping back and forth faster than light can cross the space between them, each one deciding at the last possible instant which question its photon will be asked. And still the answers agree, across the whole pattern, more than any shared plan could allow. Nothing had time to coordinate. The agreement was there anyway. Still, even Aspect's experiment did not close every gap at once. The detectors of his day, like Clauser's, caught only a fraction of the pairs. The detection gap remained, and the switching, fast as it was, fell just short of the full, airtight separation a perfectionist would demand. Two loopholes lingered, narrow and stubborn. The worry that the detected pairs were an unrepresentative sample, and the worry, subtler still, that the choices of setting were not as free as they seemed, that they might trace back somehow to the same hidden conditions that set the particles on their way. A committed defender of the local world could still, by 1982, retreat into one of these and hold out. It is worth being fair to that defender, because the integrity of the whole enterprise rests on it. The loopholes were not excuses. They were real openings in the logic, and as long as one stayed open, the verdict was not yet airtight. A result this large, a result that retires the intuitions of every human being who has ever lived, earns the right to be doubted until there is nothing left to doubt with. The good experimentalist does not resent the loophole. The good experimentalist closes it. The retreat was shrinking. It had not yet vanished. The work of sealing the last gaps would take 3 more decades and would end in a place far stranger than any laboratory in Orsay, among detectors cold enough to count a single electron's spin, and in the end, beneath light that had been traveling toward the apparatus since before the Earth had a name. But the shape of the verdict was already clear, and it is worth naming plainly what had been established and what had not, what Bell proved, and what the experiments confirmed with rising force, was not that everything is connected, and not that distant things send each other secret signals. It was narrower and harder than either. It was that the local world with definite properties, the world Einstein wrote the 1935 paper to defend, the world of separate things each carrying its own settled qualities, untouched by what happens far away. That world cannot be made to fit the facts. One of its 2 pillars must fall. Either the properties are not all definite before measurement, sitting there independent of any look, or the separation is not as complete as it appears, and what happens here is not fully independent of what happens there, or both. The experiments do not, by themselves, tell you which pillar to surrender. They tell you that you cannot keep both. This is the foundation, and it is solid. The inequality is a theorem. The violation is measured. Local realism, as the philosophers came to call the comfortable picture, is finished, not as an opinion, but as a thing the world has ruled out. Anyone is free to choose which of the survivors to live with. No one is free to keep the picture Einstein hoped to save. And the survivors are strange company, each one paying for what it keeps by surrendering something else. There is the path Bohm had already walked, the theory of definite particles guided by a wave which keeps the world real, every particle always somewhere, every property settled, and pays for it with open, unhidden non-locality, a guiding wave that feels the whole arrangement at once and reaches across any distance without apology. It keeps reality. It gives up separateness. Then there is the path that keeps locality whole and pays a stranger price. The proposal, first made by the young physicist Hugh Everett in the 1950s, that the measurement never settles into a single outcome at all, that every possible result happens, each in its own branch of a ceaselessly dividing world, and the sense of one definite answer is only the view from inside one branch. Nothing reaches across space in that picture because nothing collapses. The cost is every other world, real and unreachable, splitting off at every measurement. It keeps locality. It gives up the single world. And then there is the older path, the one running back through Bohr, the refusal to grant the particle any definite property at all until it is measured, the insistence that the quantities are not sitting there waiting to be found, but are brought into sharpness only in the act of asking. In its more recent and more radical forms, carried by physicists who treat the quantum state as a catalogue of one observer's expectations rather than a picture of the world, it gives up the idea that the properties were ever out there, independent of the look in the first place. It keeps locality of a kind. It gives up the observer-independent world. 3 doors. Realism without separateness, separateness without a single world. A single world without observer-independent properties. The experiments force you through one of them. They do not tell you which. Every physicist who has stared at this long enough has chosen a door, and the honest ones admit the choice is not compelled by the data. The data compels only this: the room you were standing in, the comfortable one, no longer exists. And yet the foundation, solid as it is, settles almost nothing about what the world actually is. It closes a door without opening another. It says the local picture is false. It does not say what true picture stands in its place. The gaps in the early experiments would close, one by one, in the decades that followed, closed at last by light that had crossed the universe to reach the apparatus. The interpretations would multiply rather than narrow, each one keeping one pillar by sacrificing the other, none of them provable, all of them strange. And underneath the whole structure, older than Bell and untouched by him, the deepest question would still be sitting in its drawer, waiting. The question of what it even means to measure, of why a look settles anything at all. The foundation had been laid. The ground beneath it had not yet been examined, and it was less solid than the foundation made it seem, and so the last doors were closed. It took until 2015, 3 decades after Orsay, but they were closed completely. In a laboratory in Delft, in the Netherlands, a team led by Ronald Hansen did the thing the earlier experiments could not. They trapped single electrons in tiny flaws inside diamonds, more than a kilometer apart, and they entangled the 2 electrons by a clever indirect route. Each one first linked to a photon. The 2 photons sent to meet at a point between them, the meeting forging a bond between the distant electrons themselves. The trick mattered. It meant that every pair they used was announced in advance, so the detectors could not quietly miss the inconvenient ones. The detection gap closed. The distance closed the locality gap at the same time. For the first time, both of the old holes were shut in a single experiment. The inequality broke again. Of course it did. Within months, 2 more groups, one in Vienna, one in Colorado, sealed the same result with photons, each closing the gaps a different way, all 3 arriving at the same answer in the same year. The verdict that Clauser had not wanted, that aspect had strengthened, was now beyond the reach of any ordinary doubt. Local realism is false, not probably false, not false except for a loophole, false with the doors shut. There is a small human detail in the Delft result worth holding. The experiment was so demanding, the bond between the distant electrons so delicate and so rare to forge cleanly, that the team gathered only a few hundred usable pairs across weeks of running, a trickle of events, each one a tiny confirmation, accumulating slowly into a result that would stand for good. No flood of data. A patient drip, night after night, until the number was undeniable. The largest claim in the foundations of physics was settled by a handful of electrons in diamond, counted one at a time. And here is where the story should have ended, and did not. Because proving the old picture false did not hand anyone a new one. The experiments told the world what reality is not. They did not tell anyone what it is. The comfortable room was gone, and in its place stood not an answer, but a corridor of doors, each opening onto a different strange account of the world, and no experiment able to say which door is the true one. The deeper you went, the less settled it became. The proof grew airtight. The meaning grew wider. Consider first how strange the closing of those last doors actually was. The worry that the early experiments left open was subtle. It was the worry that the choice of what to measure on each side might not be truly free, that the settings and the particles might both trace back to some common cause in their shared past, quietly coordinating them so that the agreement was arranged in advance after all. To rule this out, you would need the two choices to be made by something with no common history, something independent, something reaching back, ideally, almost to the beginning. So they used the stars. In 2017, a team including Anton Zeilinger, the Vienna physicist who had spent his life on these questions, ran a Bell test in which the measurement settings were chosen not by a machine in the lab, but by the light of stars. Real starlight, caught as it arrived, its color deciding the angle of each measurement at the last instant. The stars were hundreds of light years away. Any conspiracy to coordinate the settings with the particles would have had to be set in motion centuries ago, before the experiment existed, before the experimenters were born. And then they went further. They repeated it using the light of quasars, the blazing cores of distant galaxies, light that had been traveling toward the Earth for billions of years, light older than the sun, older than the planet the apparatus sat on. The inequality broke under that light too. Sit with that for a moment. To save the local world now, you would need a conspiracy, stretching back almost to the beginning of time, arranging the color of ancient quasar light so that it would, billions of years later, rig a handful of measurements in a basement. That is what is left. That is the size of the escape that remains. Most physicists do not consider it an escape at all. They consider it the cost of refusing what the simpler reading has been saying all along. The world is not locally real. The light from the edge of time agrees. There is something quiet and enormous in that image. A photon leaves a galaxy when the universe is young. It crosses the dark for 10 billion years. It ends its journey by deciding, in a single instant, which question a scientist asks of a particle. And the particle's answer, joined to its distant partner, confirms once more that the parts of the world are not as separate as they look. The oldest light we can catch was put to work answering the oldest question we can ask. So the experiments are finished. The phenomenon is real beyond reasonable doubt. And now the genuine mystery begins, because none of it tells you what is actually happening between the two particles. Start with what does not happen. Nothing passes between them. This is worth being exact about, because it is the place where almost every popular account goes soft. The correlation cannot carry a message. Look at one particle alone, and you see only noise. A random string of outcomes with no pattern in it. Nothing you could read. Nothing anyone could send. The order is invisible from either side by itself. It appears only later when the two records are carried back together, slowly, by ordinary means, and laid side by side. Only then does the agreement show itself. There is no signal. There is no influence you could use. There is only a correlation that was always there and could never be seen from one end. This is the heart of why the old phrase, action at a distance, was the wrong phrase. Nothing acts, nothing reaches. The two particles do not whisper across the gap. They behave as a single thing that happens to be described in two places, and the singleness was there from the moment they were made. There is no action, because there are not really two separate things for one to act upon the other. It is a strange thing to hold. The bond is unbreakable by distance and useless for sending anything. It is the most intimate correlation in nature, and it is silent. You cannot ride it. You cannot speak through it. You can only find afterward that the world on both sides was already of one piece. The thing that survives every distance carries nothing across the distance at all. That is not a limitation that engineering will someday overcome. It is what the bond is. What replaces the old picture then? Here the corridor of doors opens, and each door keeps something and surrenders something else. Behind one door is the pilot wave, the theory David Bohm had built. It keeps the world fully real. Every particle is always somewhere, always has a definite position, never a haze. The price is written openly on the door. A wave guides the particles, and the wave feels the whole arrangement at once, both distant settings together, instantly across any gap. The non-locality is not hidden in this theory. It is the engine. There is no spooky action only because the action is no longer spooky. It is simply there, declared, a real connection that does not weaken with distance. The world stays real. Separateness is what you give up. Behind another door is the strangest answer of all, and the one a growing number of physicists now hold. It began with Hugh Everett, the young physicist who proposed in the 1950s that the measurement never selects a single outcome. Every outcome happens. The world divides. Carried forward in our time by physicists like Sean Carroll, who has spent years arguing the case in public, and David Wallace, who has worked to make its logic airtight. This is the picture where nothing collapses and nothing reaches across space, because every result is real, each in its own branch, and what we call the single outcome is only the slice of the whole that one version of us can see. It keeps locality perfectly. Nothing travels, because nothing is ever resolved into one. The price is every other world, and a subtler price as well, one its own defenders take seriously. If everything happens, it becomes hard to say what the probabilities even mean, why some outcomes should feel more likely than others when all of them occur. That problem has a long technical literature and no agreed solution. It is honest to name it. The single world is what you give up, and the meaning of chance comes loose in your hands. Behind a third door, the quantum state is not a thing in the world at all. In the view called cubism, carried by the physicist Christopher Fuchs, the wave function is not out there. It is a tally of one observer's expectations, a personal accounting of what that observer should expect to see, updated when they look. On this reading, there is no spooky action because there is nothing physical doing the acting. There is only a person revising their expectations the instant they learn something new. It keeps locality. It gives up the idea that the quantum state was ever a picture of the world, independent of anyone's knowledge of it. And behind a fourth door, collapse is real, genuinely real, a physical event, not a trick of perspective. Roger Penrose, the mathematician who shared a Nobel for his work on black holes, has argued for decades that the collapse is triggered by gravity itself, that the weight of a thing becoming definite is what tips it into a single outcome. Unlike the others, this door makes a prediction that experiments may one day test. The collapse, if it is real, should leave a trace. So far, the traces have not been found, and the searches continue. 4 doors, none of them proven. No experiment yet that forces you through one rather than another. The mathematics is the same behind every door, the same equations, the same predictions, confirmed to staggering precision. What differs is the story of what the mathematics means, and the mathematics does not tell its own story. This is the measurement problem in its full weight. It is not a puzzle waiting on a better instrument. It is open at the foundation. It has been open for 90 years. Anyone who tells you it is closed has chosen a door and forgotten that it was a choice. And there are rooms stranger than these 4, for those willing to walk farther down the corridor. The physicist Yakir Aharonov, who spent his life looking for what others had not, built a way of describing quantum events that almost no one expected. In the ordinary telling, the state of a particle is fixed by its past. by how it was prepared, by what came before. What Aharonov's two-state vector formalism makes mathematically explicit is that every quantum event can be described as shaped by boundary conditions from both directions in time, one condition flowing forward from the past, one condition flowing backward from the future. This is not mysticism, and it is not a claim that the future reaches back to change the past in any way you could use. It is a feature of the formalism, a second, equally valid way of writing what is already there in the equations, in which the symmetry between past and future, hidden in the usual telling, comes into view. Most physicists set it aside. A few think it is pointing at something real. No one can yet say. It is one more door in a corridor that keeps revealing doors. Let the corridor stand quiet for a moment, all its doors ajar. The patient work of a century has brought us here, to a place where the more certain we became of the facts, the less certain we became of their meaning. There is a kind of honesty in standing in that corridor and not pretending to know which door is real. It is the honesty of the open question, held open, on purpose. Now, two quiet facts about the bond itself, because they matter for everything that has been built on it. The first is that this bond is jealous. Entanglement is monogamous. If two particles are bound together as completely as the equations allow, neither one has anything left to share. They cannot be that deeply entangled with any third thing. The bond, at its fullest, is exclusive. It is not a web spreading freely through the world, linking everything to everything. It is a closed pair, and the closing of the pair shuts the rest of the world out. The second fact is that the bond is fragile. Bring an entangled particle into contact with a warm, busy environment, air, light, the ordinary jostle of the everyday world, and the entanglement bleeds away almost at once, scattered into the surroundings faster than any instrument can follow. This bleeding has a name, decoherence, and it explains a great deal. It explains why we do not see large things in two states at once, why the strangeness stays hidden at the scale of tables and hands and bodies. The entanglement does not vanish. It spreads into the environment until it can no longer be gathered back. The world looks classical because the strangeness has leaked into everything around it. But here, the honesty must hold firm, because decoherence is often asked to do more than it can. It explains why the strangeness becomes invisible. It does not explain why, in the end, one single outcome is the one that happens. It turns the many into the apparently one. It does not pull the trigger. The selection of this result rather than that one, the actual becoming definite of the world, sits exactly where it always sat, untouched, behind the four doors. Decoherence narrows the mystery. It does not dissolve it. This distinction is missed constantly, and it is the difference between a hard problem softened and a hard problem solved. So the bond is exclusive, and the bond is delicate. Hold those two facts. They will matter. It is worth letting them sit, because they cut against the picture most people carry. The bond does not spread softly through the world, joining all things to all things in a warm, invisible mesh. It is the opposite of that. It is rare. It is hard to make and easy to destroy. It closes around a pair and shuts the world out, and the faintest touch of ordinary warmth undoes it. Whatever the non-separability of the world turns out to mean, it is not a gentle web you could lean into. It is something stranger, colder, and far more precise. Remember that. There will be a place, later, where it is the only thing standing between a true statement and a comfortable lie. And now the mystery turns, in the last decade, towards something larger than any single pair of particles, toward the suspicion that this bond is not a curiosity inside space, but part of what makes space in the first place. In 1935, the same year Einstein put his name to the entanglement paper, he put his name to another. With Nathan Rosen, the same Rosen, he described a kind of bridge in the fabric of space-time, a tunnel connecting two distant regions through a shortcut outside ordinary space. We call it a wormhole now, an Einstein-Rosen bridge. For 70 years, these two papers sat in different corners of physics, unrelated, two separate strange ideas from a single strange year. One about particles bound across distance, one about geometry folded across distance. No one thought they had anything to do with each other. Then, in 2013, two physicists looked again. Juan Maldacena and Leonard Susskind proposed something with the compactness of a riddle. The bridge and the bond might be the same thing. Two black holes, entangled with each other, might be joined, literally, geometrically, by a wormhole through the fabric between them. The entanglement and the tunnel would be two descriptions of one reality. They wrote the idea as an equation that reads almost like a line of poetry. The bridge equals the bond. Two strange papers from 1935, the suspicion now runs, were quietly describing the same depth from two sides, and the man who wrote both of them never knew. If that is right, and it is conjecture at the very edge of what physics can test, then entanglement is not something that happens across space. It is something that space is made of. This is the thought that has pulled at a generation of physicists since. The proposal, developed by Mark van Ramsdonk and others, runs like this. Take two regions of space. Reduce the entanglement between them gently in the mathematics. As the entanglement falls, the regions drift apart. The space between them stretches and thins. Reduce the entanglement to nothing, and the two regions pinch off entirely, no longer connected by any space at all. Turn the entanglement back up, and the geometry knits itself back together. In this picture, the distance between two places is a measure of how entangled they are. Space is not the stage on which entangled particles sit. Space is woven out of the entanglement itself. Pull the threads, and the fabric comes apart. There is a precise mathematical relationship underneath this, a formula relating the entanglement between two regions to the geometry of the surface between them, worked out by the physicists Shinsei Ryu and Tadashi Takayanagi. It is part of the broader idea that our three-dimensional world might be written, in full, on a distant two-dimensional boundary, the way a flat surface can hold a complete image of a solid scene. The holographic principle, it is called. And entanglement is the thread that stitches the image into a world with depth. It must be said plainly what this is and is not. This is not established physics. It is a frontier, a set of deep conjectures at the place where quantum theory and gravity are still being forced, with great difficulty, to speak to each other. No experiment confirms that space is built from entanglement. The idea lives, for now, in the mathematics, and the mathematics is suggestive and beautiful and unfinished. What is real is that serious physicists, working on the hardest unsolved problem in the field, keep finding that entanglement sits at the center of it. The thread keeps turning up in the weave. Whether it is the weave itself, no one yet knows. There is a strange comfort hidden in this, and a strange vertigo. You have looked across a room at someone and felt the distance between you as something solid, a real space that words have to cross. If these physicists are even partly right, that distance is not the fundamental thing. The space between any 2 points may be the surface appearance of how bound or unbound they are underneath. The separation is real. It may also be woven and not given. The thought does not resolve into anything you can hold. It only opens. And that phrase, "no one yet knows," is the true resting place of this whole movement. Stand back then and see the shape of what has been built and what has not. What is established is solid and astonishing. The bond is real. The world is not locally real. The experiments have shut every door on that, down to the light of quasars. The bond carries no message, and yet it cannot be explained as two separate things with separate properties. All of this is known. What is suggested, and not yet known, is larger still, that this same bond may be the thread from which space itself is woven, that separateness may not be fundamental even to geometry. And what remains genuinely unknown sits beneath all of it, exactly where it has sat for 90 years. No one knows what measurement is. No one knows why a single world becomes definite out of the haze. No one knows which of the doors is the true one, or whether there is one no one has yet found. It is worth being honest about the temptation that arrives here, because it arrives for everyone. When physics reaches a genuine edge, when the experts themselves cannot agree, when the mathematics goes quiet about its own meaning, there is a pull to fill the silence with something, to decide that the openness means something in particular, to reach for a conclusion the evidence has not earned. The discipline is to refuse that pull. The open question is not a doorway to whatever one wishes were true. It is only what it is, a place where the knowing stops, honestly marked. The mathematics is consistent. The experiments are confirmed. The interpretations are many, and they do not agree, and nothing in the data chooses between them. Physics has done something rare and honest here. It has followed a question all the way down to the place where its own tools run out, not because the tools failed, but because the question, at the bottom, is about what reality is, and reality has not finished telling us. The strangeness is not a gap to be filled by a cleverer experiment next year. It is built into the floor. What is left when the experiments are done and the equations are consistent and the meaning is still open is a single quiet fact standing in the middle of physics like a stone. The parts of the world are not separable. The separation we see and live inside is real on the surface and not real underneath, and physics cannot yet say what the underneath is. The question has become precise. The answer has not arrived. And a precise question with no answer is a particular kind of silence, not the silence of ignorance, but the silence of standing at the edge of what can be known, looking out. That edge is old, far older than the experiments that finally led us to it. Long before there was a laboratory anywhere on Earth, before there was a single equation, human beings stood at this same edge by another road entirely, and looked into the same question of whether anything truly stands apart from anything else, and came back with something to say. They came back with something, and it is worth being careful from the first word about what kind of something it was. They did not run experiments. They built no apparatus, set no detector, wrote no inequality. They went the other way entirely, inward, into the structure of experience itself, examined under conditions of stillness so prolonged and so disciplined that it is hard for most of us to imagine the patience involved. Years of it, lifetimes, and out of that long looking, more than one of them arrived at a picture of reality in which separateness is not the final truth. The parts of the world do not stand fully apart. This is not a thing physics proved, and they anticipated. It is a thing they found by their own road, and the road has nothing in common with the laboratory except where it arrives. That distinction has to be held with both hands through everything that follows, because it is the easiest thing in the world to drop. The physics did not confirm the contemplatives. The contemplatives did not predict the physics. Nothing here is being validated by anything else. What is being noticed is narrower and stranger than validation. It is that two utterly different methods of investigation, one turned outward to the measurable world, one turned inward to the structure of awareness, keep arriving at the same shape, not the same words, not the same claims, the same shape. And the traditions that found it did not even agree with each other. They argued, for centuries, about almost everything. They converge on the architecture and diverge on nearly all the rest. That makes the convergence more interesting, not less. A word about how these will be set down, so the listener is not misled. Each of these traditions is a vast and living thing, with its own internal disputes, its own centuries of refinement, its own teachings that take a lifetime to enter. What follows touches only the single thread in each that bears on this one question, the question of whether anything truly stands apart. It is not a survey. It is not a fair summary of any of them. It is one careful cut through each, made at the exact place where the architecture shows. The rest of each tradition, immense and beyond this telling, stays where it is. Begin where the analysis went deepest. In the 2nd century, in southern India, a Buddhist monk named Nagarjuna did something that still has the power to unsettle anyone who follows it carefully. He did not build a doctrine. He took doctrines apart. In a terse and difficult text, the root verses on the middle way, the Mula Madhyamakakarika, he examined one thing after another, motion, time, the self, causation, and asked of each whether it possessed any independent existence of its own, any nature it carried in itself, apart from everything else. The technical term is own being, or inherent self-nature, svabhava, and his finding, pressed relentlessly through every case, was that nothing has it. Nothing stands on its own. Everything that appears only in dependence on what it is not. This is the teaching usually translated as emptiness, shunyata, and almost everything said about it in popular books is wrong in the same way, so it is worth stating precisely. Emptiness does not mean that nothing exists. It does not mean the world is an illusion, a dream, a projection. It means that things are empty of independent existence, empty of svabhava, and nothing more than that, and nothing less. A thing is real. It simply is not real on its own. It exists the way a flame exists, only in dependence on fuel, on air, on heat, with no flame in itself hiding behind the burning. Pull the conditions apart, and you do not find a core that was the flame. There was never a core. There was only the dependent arising, pratyasamutpada, the mutual coming into being of things that have no being apart from each other. And here, Nagarjuna did the move that the lineage holds as the heart of it, the move that almost every popular account walks straight past. He turned the analysis on emptiness itself. If emptiness were a real thing, a ground, an absolute, a single reality underneath the appearances, then emptiness would have svabhava, would have the very inherent existence that the whole analysis denies. So emptiness, too, is empty, empty of itself. It is not a hidden substance behind the world. It is not the one. It is not a cosmic ground in which all things rest. It is the simple absence of independent existence, and that absence does not itself exist independently. Nagarjuna dismantled all four possibilities about anything: that it exists, that it does not exist, that it both does and does not, that it neither does nor does not. And when the four were gone, he did not erect a fifth. He left the question standing open. What remained was not nothing. It was something he refused to name, because to name it would be to give it the inherent existence he had just spent the whole text removing. So now the popular version, and why it matters that it is wrong. It is often said that the great contemplative discovery is that all is one, that separation is illusion and unity is the truth, that underneath the many lies the one, and the spiritual task is to dissolve back into it. This is the single most repeated idea in popular spirituality, and Nagarjuna's analysis cuts directly against it. Oneness is just separateness wearing a different robe. A single unified ground, a cosmic one in which all distinctions melt. That is a thing with inherent existence, a svabhava at the largest possible scale, and it falls to exactly the same analysis as everything else. Madhyamaka does not teach that all is one. It teaches that things are neither many nor one, neither separate nor fused, because both separate and one assume the inherent natures that are not there. The actual teaching is more precise and far more demanding than the comfort it gets flattened into. It does not let you rest in unity. It does not let you rest anywhere. This is the place to mark a distinction that the popular blur erases completely, and that the traditions themselves spent centuries arguing over. Because there is another of the great contemplative systems that does teach oneness, really teaches it rigorously as the deepest truth. In the Hindu tradition, the school of non-duality, Advaita, articulated most powerfully by the philosopher Shankara in the 8th century, reading the oldest layer of the Upanishads, holds that there is one reality without a second, one ground called Brahman, and the world of separate things is appearance laid over it, the way a rope in dim light is taken for a snake. The famous teaching from the 6th chapter of the Chandogya Upanishad, "You are that tattvam asi," is the sage Udalaka instructing his son that the innermost reality of the self is identical with the single being underlying all things. That is monism, one substance. The many are appearance. The one is real. And here is what almost no popular account will tell you. These two systems, Nagarjuna's emptiness and Shankara's non-duality, are not the same teaching. They are not even compatible teachings. They are precise opposites on the exact question that matters here. Advaita affirms one absolute ground. Madhyamaka denies any absolute ground at all, including the one. For over 1,000 years, their inheritors debated this, sharply, knowing exactly what divided them. The popular spirituality that says the mystics all agree that all is one has flattened two of the most rigorous metaphysical systems ever produced into a slogan that one of them explicitly refutes. The lineage holders did not agree. The disagreement was the whole point. So, which of them does the physics resemble? Neither, cleanly, and this is the part worth slowing for. The entangled pair has no independent state. The properties are not sitting in each particle on its own, waiting to be read. They exist only in the relation. That is structurally close to dependent arising. Existence only in relation, no svabhava, no property in itself. But notice what the physics does not deliver. It does not deliver a single underlying substance, a one that the two particles secretly are. There is no cosmic ground revealed in the equations. There is only relation without inherent relata, a non-separability that is also not a fusion. The shape the physics arrives at is closer to Nagarjuna than to Shankara. Relation without a ground. The middle exactly, between the many and the one. The languages are different. The methods could not be further apart. Nagarjuna ran no experiment and proved nothing about photons. Bell measured nothing about emptiness. This is not validation. It is recognition. The recognition that an analysis of experience pressed to its limit and an analysis of matter pressed to its limit arrived at the same refusal. The refusal to grant things an independent existence they turn out not to have. Nagarjuna left an image for it, in a way, though he would have refused the word image. Look for the thing, he said in effect, and you will not find it, not in its parts, not in the whole of its parts, not somewhere apart from its parts. The self is not the body, not the mind, not the sum of them, not a thing standing behind them. And yet there is experience. There is a person here. The person is real and is found nowhere, because the person was never a thing in itself to be found. Hold that. It returns. There is one more piece of the machinery that the lineage carries and the popular version drops, and it keeps the whole teaching from tipping into nihilism. Nagarjuna spoke of two truths. There is the conventional truth, in which tables are tables and people are people, and the ordinary world functions exactly as it appears to. And there is the ultimate truth, in which none of these things possesses inherent existence. The two are not rivals. The ultimate does not cancel the conventional. Emptiness does not mean the table is not there. It means the table, fully present and usable, has no independent being underneath its appearing. You have known this without the doctrine. You have looked hard at something you were certain was solid and singular, a feeling, a self, a fixed fact about who you are, and watched it come apart into conditions, into causes, into things that were not it, until the solid thing you started with was nowhere to be found, and yet your life went on being lived. That is the two truths, felt from the inside. The world works. Nothing in it stands alone. There is a second Buddhist school that took the same insight and turned it in a different direction, toward the way the whole shows up inside each part. In 7th century China, a master named Fazang served at the court of the Empress Wu Zetian, and he is remembered for a demonstration he is said to have staged for her. He built a hall of mirrors, mirrors on the walls, the ceiling, the floor, and in the center, a single small statue of the Buddha with a lamp beside it. The light caught every mirror, and every mirror caught every other mirror, and the single image multiplied into an endless depth of reflections, each reflection containing all the others, the whole hall present in every fragment of every glass. He was showing her the teaching of his school, the Huayan, the flower garland school, drawn from a vast and strange sutra of the same name. The teaching is mutual interpenetration. In the technical phrase, the non-obstruction of phenomenon and phenomenon, shi shi wu ai. Everything contains every other thing. The whole is present in each part, and each part is present in the whole, without anything being lost. The classical image, older than Fazang, is the net of the god Indra, a net stretched across infinity, with a jewel at every knot, and every jewel reflecting every other jewel, and reflecting the reflections, without end. The school built this out into a precise structure, and the structure is the hidden content most accounts never reach. The world, in the Huayan analysis, can be seen as 4 realms, 4 ways of looking that go progressively deeper. There is the realm of separate things, the world as it ordinarily appears, distinct phenomena, each in its place. There is the realm of underlying principle, the emptiness running through all of them, There is the realm in which principle and phenomenon do not obstruct each other, where the emptiness and the appearing are seen to be the same movement. And then there is the fourth and deepest realm, the one Fazang's mirrors were built to show. The non-obstruction of phenomenon and phenomenon, where each particular thing without any intermediary contains and reflects every other particular thing directly, not joined through a common ground, joined immediately, each to each, the whole net alive in every knot. That fourth realm is the one the popular "everything is connected" never reaches, because it is not connection at all in the ordinary sense. It is mutual containment. Now here is where nearly every popular account goes wrong, and the error is precise. The pop version says, everything is interconnected. All things are linked in one great web. We are all connected. And it imagines this as a kind of merging, boundaries softening, things flowing into one another, distinction dissolving into a warm unity. That is exactly what Huayan does not teach. The structure the school worked out, with a rigor that reads almost like mathematics, insists on the opposite. The jewels do not melt into one jewel. Each remains completely, sharply itself. The interpenetration preserves the particular. It does not dissolve it. Each jewel contains all the others precisely as a distinct jewel, and would lose the containing if it lost the distinctness. It is not fusion. It is total mutual presence without any loss of difference. The whole in the part, and the part still the part. That is far stranger than a web and far more precise, and the strangeness is the content. And the structure has a shape that physics has been circling at its own frontier. The proposal that space itself may be woven from entanglement, that the whole may be encoded in its parts, the way a flat boundary can hold a solid world, the holographic idea, is in its architecture the net of Indra, the whole reconstructible from the part containing the whole, and in the deepest versions, the distinctions preserved, even as everything interpenetrates everything. Fazang built a hall of mirrors for an empress. 13 centuries later, physicists writing equations about black holes and information found themselves describing a reality in which the whole is present in each region, stitched together by the same bond this entire investigation has been following. Neither knew the other. The map drawn in a Chinese palace and the map drawn at the edge of quantum gravity from different continents and different millennia look strangely alike. The structure is the same. The methods share nothing at all. Move west now and forward a few centuries to a tradition that held the same paradox, unity and distinction at once, and built an entire metaphysics around the place where they meet. In the 12th and 13th centuries, in Muslim Spain and later in Damascus, a Sufi master named Ibn Arabi developed a teaching the Orthodox tradition would spend 600 years trying to suppress, sanitize, or explain away. It is usually translated as the unity of being, Wahdat al-Wujud, and read carelessly. It sounds like the flattest pantheism. All is God. Everything is one divine substance. The world is God, and God is the world. That reading is why they tried to suppress it, and that reading misses what Ibn Arabi actually built, which is far subtler and turns on a single concept that almost no popular account carries. The concept is the isthmus, the in-between, barzakh. A barzakh is that which stands between two things, joining them while belonging fully to neither. The line where the sea meets the land is a barzakh, not sea, not shore, the boundary that both divides and unites them. Ibn Arabi made this the center of his ontology. Reality, for him, is not a flat oneness. It is a unity shot through with barzakhs, with in-between regions where opposites are held together without collapsing into each other. The unity of being does not erase the distinction between the divine and the world. It holds them in a relation mediated by an endless series of these between places, each one joining what it also keeps apart. And the deepest of them is the imaginal realm, Hadrat al-Khayal, which later readers, unable to accept it, demoted into mere imagination, a psychological fancy. For Ibn Arabi it was nothing of the kind. It was a real domain of being, ontologically intermediate, where meanings take on form and forms carry meaning, neither pure spirit nor pure matter, but the barzakh between them. The sanitizing of that realm into just imagination is one of the quiet thefts in the history of these traditions. And the barzakh is a shape this whole investigation keeps meeting. The entangled state lives in a between. It is not fully located in this particle, not fully in that one. It is the single state of both, joining them across the distance while they remain, in space, entirely distinct. Unity and separation held together, neither collapsing into the other. The bond unites the two particles into one description. And yet, recall the strange fact from the experiments. It carries no message, transmits nothing, leaves each particle looking separate and ordinary on its own. Unity that does not erase distinction. Distinction that does not break the unity. That is the barzakh structure, exactly, the between that joins and separates at once. Ibn Arabi sat in contemplation in Andalusia, and arrived at it by following the architecture of the divine. The physicists arrived at it by following the statistics of polarized light. Physics did not confirm the Sufi. The Sufi did not predict the physics. The shape is the same. It is worth pausing on why the Orthodox tradition fought this teaching so long and so hard, because the reason is instructive about how the deep version of a tradition gets buried. A flat oneness, all is God, is easy to condemn as heresy and easy to dismiss. But that was never quite what Ibn Arabi said, and the careful readers knew it. What he offered was harder to refute and harder to live with. A unity of being that did not abolish the distinction between the Creator and the world, that kept the worshipper and the worshipped genuinely distinct, while affirming that there is, in the end, only one being. The barzakh is what let him hold both at once. And a teaching that holds both at once cannot be filed away as simple pantheism and cannot be reconciled with simple dualism either. It sits in the between. So for 6 centuries, the commentators worked to soften it, to read the unity down into metaphor, to turn the imaginal realm into mere fancy, not because the teaching was empty, but because it was too full to sit quietly inside the categories the Orthodox needed. The sanitizing was not the correction of an error. It was the burial of a difficulty. There is a 4th road, older than all of these, and it found the relation at the root of things by attending not to mind or to the divine, but to the way opposites bring each other into being. In China, more than 2,000 years ago, the text we call the Tao Te Ching set down a vision of the way, the Tao, from which all determinate things arise, and it stated very early that nothing stands alone. Being and non-being produce each other. Difficult and easy complete each other. Long and short give each other shape. High and low depend on each other. Before and after follow each other. Nothing carries its nature in itself. Everything is what it is only in relation to what it is not. And here, in the hidden layer, is something most readers of this most translated of books never learn. There is no single Tao Te Ching. The text comes down to us through commentaries, and 2 of the greatest produced 2 different Taos. In the 3rd century, a brilliant young metaphysician named Wang Bi, who died at 23, read the Tao as fundamental non-being. Wu, the the no thing that is not itself any particular thing, and precisely for that reason can be the source of all particular things. His Tao is an ontological ground that is not a being, a fullness that looks like emptiness. The other great commentary, attributed to a figure called Heishang Gong, reads the very same text physiologically and cosmologically. The Tao as the breath and vital process moving through the body and the world, a teaching for cultivation and long life. The same words, two radically different Taos. One, a metaphysics of non-being. One, a physiology of vital process. The popular version, which renders the whole thing as a soft counsel to relax and go with the flow, has not even noticed that the tradition itself could not agree on what the Tao is. But on the relation, the text is clear, and it is the relation that matters here. There is a contemporary reading of quantum mechanics, the relational interpretation, developed by the physicist Carlo Rovelli, which holds that a system has no properties on its own at all. A particle's state is never absolute. It exists only in relation to another system, defined in the interaction and nowhere else. Properties are not possessed. They are relational, through and through. Set that beside the opening of the Tao Te Ching, being and non-being producing each other, nothing carrying its nature in itself, and the architecture is the same. No inherent property, only mutual arising. Laozi, or whoever composed those aphorisms, wrote in images and silences. Rovelli writes in operators and equations. The territories are different continents. The maps rhyme. There is a word the Taoists used for how things behave when nothing is forcing them, self-so, or so of itself, ziran. A thing left to its own nature does what it does not by command from outside, but by what it is in relation to everything around it. The water flows downhill, not because it is pushed, but because flowing downhill is what water in its relations is. Nothing has to be added. The behavior arises from the web of relations itself, and the wisest action, the action that is barely an action, Wu Wei, is the action that moves with that grain rather than against it. This is not the soft counsel it is usually sold as. It is a claim about how reality is structured, that things are constituted by their relations so completely that the right move is to stop treating them as separate objects to be pushed, and to act instead as a part of the relation one already is. The popular reading takes the calm and leaves the metaphysics. The metaphysics is where the calm comes from. The Taoist tradition kept one image for this that says it more cleanly than any argument. 30 spokes meet at a single hub, the text observes, but it is the empty center, the hole where they all join, that makes the wheel turn. The clay is shaped into a vessel, but the use of the vessel is the emptiness inside. The usefulness is in what is not there. The thing works by virtue of what it lacks, by the relation, by the space, by the absence at the center that lets the parts be a whole. Look for the wheel in the spokes, and you will not find it. Look for it in the hub, and you will not find it. The wheel is in the relation, and the relation runs through an emptiness. So 4 roads, and they do not lead to the same doctrine. Set them honestly side by side, and they argue. The emptiness of Nagarjuna refuses the very ground that Shankara's non-duality affirms. The Sufis' unity of being would have been heresy to half of them, and was nearly heresy in its own house. The Taoists could not agree among themselves what the Tao even was. These are not one perennial teaching wearing 4 costumes. They are distinct, rigorous, often incompatible systems, built by people who would have disputed each other fiercely, and that is exactly what makes the one thing they share worth noticing. On the architecture, they converge. A reality in which things have no independent existence, in which the parts are not finally separable, in which the whole is somehow present in each part, in which unity and distinction are held together without either dissolving the other. 4 different roads, 4 different destinations, and the ground beneath all 4 turns out to have the same shape. And now, the thing that must be said plainly, because the failure to say it is where almost everyone goes wrong. None of this means the ancient sages knew quantum mechanics. They did not. It is often claimed, in 1,000 books and 1,000,000 posts, that the mystics foresaw modern physics, that ancient wisdom predicted what science has only now confirmed, that the sages were quantum physicists in robes. This is false, and it is worth being exact about why. The contemplatives made no predictions. They ran no experiments. They could not have told you a single thing about a photon, a polarizer, an inequality. They were not doing physics in disguise. They were doing something else entirely, and doing it on its own terms. And the physics, looked at honestly, refuses the fantasy from its own side. Recall what the bond actually is. It is fragile, destroyed by the faintest warmth. It is jealous. A full bond with one partner shuts out all others. It carries nothing, says nothing, cannot be used. It is nothing like a warm web of cosmic consciousness linking all beings in love. Anyone who reaches for the physics to prop up that picture has not understood the physics. The bond is cold, precise, exclusive, and silent. It will not hold the weight that the comfortable reading wants to hang on it. What actually happened is rarer than any prophecy, and harder and better. 2 ways of investigating reality, separated by 2,000 years and sharing no method, no instrument, no vocabulary, arrived independently at the same structural refusal, the refusal to grant the world its apparent separateness as the final word. That is not the past predicting the future. It is not wisdom anticipating science. It is convergence. And convergence between wholly independent investigations is the strongest kind of signal there is. Not a proof of any doctrine, but a sign that the shape both of them keep meeting may be a real feature of the way things are, and not an artifact of either method. Physics did not confirm the traditions. The traditions did not predict the physics. The convergence is architectural, and it asks to be understood as exactly that, no more, which would be dishonest, and no less, which would be blind. It helps to be precise about what kind of signal convergence is, because it is easy to overweight and easy to dismiss. When 2 people copy from the same source, their agreement tells you nothing. It is one observation wearing 2 faces. But when 2 observers who have never met, using instruments built on different principles, looking from different angles, report the same feature, the agreement becomes hard to explain as accident. The contemplatives and the physicists are the second kind. They share no source. One looked outward at matter, one looked inward at mind. Neither could have copied from the other, because for most of the history involved, neither knew the other's work existed. So when they keep meeting the same shape, things without independent existence, parts that will not fully separate, a whole somehow present in each part, that meeting is not nothing. It is also not everything. It does not tell you that any tradition's full doctrine is true. It does not tell you that the physics carries any spiritual meaning. It tells you only that the shape may be real, and that 2 roads found it, and that is precisely as much as it tells you. What remains is to ask what such a convergence is worth, what it establishes, what it merely suggests, and what even now, with the experiments done and the traditions read in their own words, no one is in any position to claim. So what does all of this mean? Not for physics. What it means for physics is now reasonably clear and can be stated plainly. The harder question is the one underneath. What does it mean that the world is built this way? What does it mean to be a separate thing in a reality where separation is not the final truth? What is this? The honest way to answer is to refuse the single answer and to sort carefully what is known from what is guessed from what no one knows at all. That sorting is not a small thing. It is most of wisdom in any field, the discipline of holding each claim at exactly the weight it has earned, and not a gram more. The popular versions fail here, on both sides. The materialist version overstates what the physics settles. The spiritual version overstates what the convergence proves. The honest position is narrower than either, and it asks more of the person holding it because it will not let them rest in a conclusion. It only lets them stand on the ground. There is a discomfort in this that is worth naming, because most accounts rush past it to get to a verdict. The mind wants the verdict. It wants to know whether the world is, in the end, just particles and equations, or whether there is something more, some depth the equations are pointing at. It wants to be told, and the truthful answer disappoints that want, on purpose, because the truthful answer is that the question is still open, and the wanting does not close it. To stay with an open question without forcing it shut in either direction is a kind of discipline that neither the laboratory nor the monastery makes easy, and both, at their best, make possible. So let the ground be sorted plainly into its three layers, the solid, the suggested, and the open, and let each be named for what it is. Begin with what is solid, because it is astonishing, and it is not in doubt. The bond is real. Two particles, once joined, stay correlated in a way that no story of separate things carrying separate properties can explain. This is not a theory. It is a measured fact, confirmed in laboratory after laboratory, with the last escape routes closed one by one until the only ones left required a conspiracy reaching back to the light of distant quasars. The world is not locally real. That phrase carries the whole weight of a century of work. It means that you cannot have both of two comfortable beliefs at once, that things have definite properties before they are looked at, and that nothing here is instantly bound up with anything there. One of them is false. The experiments do not say which. They say, with finality, that you cannot keep both. It is worth holding how complete this is, because completeness is rare in the deep questions. This is not a result that holds for now, pending a better experiment. The better experiments were done. They closed the gap where the detectors might have been hiding a biased sample. They closed the gap where some slow influence might have crept between the two sides. They closed the gap where the choices might have been secretly arranged, by letting ancient starlight make the choices. Each refinement could have rescued the comfortable picture. None did. The result only grew firmer the harder it was pushed. There is no serious expectation among physicists that it will reverse. The door is shut, and the shutting was checked, and checked again, by people who would have been famous for prying it back open. In 2022, the prize that physics gives its own was given for exactly this, to three of the people who built the experiments that settled it, the ones who took a philosophical quarrel and turned it into a measured result. The strangeness that Einstein wrote his famous paper to banish, the thing he called spooky and could not accept, is now among the most precisely confirmed facts in all of science. There is a quiet justice in that, and a quiet irony. He was the one who saw the strangeness most clearly. He built the sharpest version of the paradox precisely because he was sure it pointed to a flaw. And the paradox he built to defend the ordinary world became the tool that dismantled it. He was right that it was strange. He was wrong that the strangeness would dissolve. It did not dissolve. It deepened, and it was honored, and it stands. And one more thing is solid, and it cuts against the comfortable reading as sharply as anything. The bond carries nothing. No message moves along it. No influence you could use. Each particle, on its own, shows only noise, and the order appears only when the two records are brought back together by ordinary means, slower than light. This has been part of the established picture from the beginning, and it is the firmest guard against every fantasy built on top of entanglement. The bond is real, and it is silent. Hold both. They are both true, and the second keeps the first honest. It is worth dwelling on that guard, because it is the place where so much of what gets said about this subject quietly falls apart. The bond is not a warm thread of cosmic feeling running through all things. It is fragile, undone by the faintest touch of ordinary warmth. It is jealous. Bound fully to one partner shuts out every other. It is silent. It carries no word, no will, no influence you could ever send or receive. Everything true about it points away from the soft picture of a universe humming with connection you could lean into or draw upon. What the physics actually found is colder, stranger, and far more precise than that picture, and far more interesting. The separateness of the world is not the final truth, but the thing underneath the separateness is nothing you could use, and nothing that would comfort you, and saying otherwise is the one move this whole account refuses to make. Now the second layer, what is suggested, pointed toward, made plausible, but not established. Here the voice has to change, and the change matters. Because in the last decade, at the hardest edge of physics, a possibility has taken shape that goes far beyond any laboratory result. It is the possibility that this bond is not something that happens inside space, but something space is made of. That the geometry we live in, distance, nearness, the very fabric that holds things apart, is woven out of entanglement and would come undone without it. The mathematics that suggests this is serious and beautiful, and the work of some of the best minds in the field. It is also unproven. No experiment confirms it. It lives for now in the equations, at the place where quantum theory and gravity are still being forced to speak. It may turn out to be the deepest insight of the century. It may turn out to be a beautiful wrong turn. Both have happened before. What is suggested is not what is known, and the distance between them is exactly the distance a careful person keeps. There is a strange grace note buried in this for anyone who knows where to look. The same man who put his name to the entanglement paper in 1935 put his name, that very same year, to the paper that first described a bridge through the fabric of space, a tunnel joining two distant places through a shortcut outside ordinary geometry. He thought the two ideas had nothing to do with each other. He spent his later years troubled by the first and largely set the second aside as a curiosity, and the suspicion now circulating at the frontier is that they were the same idea all along, that the bond between particles and the bridge through space are two faces of one thing, and that the man who described both never knew he had described the same depth twice. If that is right, it is one of the strangest quiet ironies in the history of the field. But the word is if. It is a conjecture, held by serious people, confirmed by no one. It belongs in the middle layer, and it must be kept there. And the convergence itself belongs to this middle layer. The strange fact that contemplatives, by a method that shares nothing with physics, arrived at the same architecture. That is suggestive. It is not proof. It suggests gently that the shape both roads keep meeting may be a real feature of reality rather than an artifact of either way of looking. But a suggestion is all it is. The convergence cannot tell you that any tradition's full teaching is true, and it cannot lend the physics a meaning the physics does not contain. It can only raise, quietly, the probability that the thing both of them keep finding is actually there. That is worth something. It is not worth everything. It sits in the middle layer, where honest things that are not yet known are kept. And then the third layer, the deepest and the largest, what remains genuinely unknown. This is the center of the whole matter, and it does not shrink no matter how much is learned around it. No one knows what measurement is. No one knows why. Out of the haze of possibilities the equations describe, a single definite world is the one that happens. The thing that turns the many into the one, the actual becoming real of a particular outcome, sits exactly where it has sat for 90 years, behind every interpretation, explained by none of them. Decoherence narrows the mystery and does not solve it. The interpretations multiply and do not agree, and nothing in the data chooses between them. Pick whichever you can live with. The branching worlds, the guiding wave, the personal state, the real collapse, and know that you have chosen, and that the choice was not forced by anything anyone has measured. It is worth feeling the strangeness of this, because it is not the ordinary strangeness of a hard, unsolved problem. Most unsolved problems are gaps, places where the knowledge has not yet reached, but where everyone agrees what a solution would even look like. This is not that. Here the equations are complete. They predict everything that can be measured to more decimal places than almost anything else in science. There is no missing experiment, no quantity left uncalculated, and yet no one can say what the equations are describing. The mathematics works perfectly and stays silent about its own meaning. A theory that tells you exactly what you will see and refuses to tell you what is there, that is a stranger thing than a mere gap. It is a completed map of a territory no one can visit. 90 years of the finest minds in physics have not been able to say what the map is a map of. That is the unknown at the center, and it is not getting smaller. And beneath even that sits the largest unknown of all, the one this whole telling has circled without ever closing. We do not know whether the non-separability that physics has found and the non-separateness that the contemplatives reported are the same depth or merely the same shape seen twice from very far apart. They look alike. The architecture rhymes. But whether they are two reports of one reality or two unrelated truths that happen to share a silhouette is not something anyone can say. It may be that no one will ever be able to say it. The question might be permanently open, not open because the next experiment will close it, but open in the way the deepest questions are open, the way that is not a temporary gap in knowledge, but a standing feature of standing where we stand. We do not know. Those 3 words are not a failure here. They are the most honest thing in the whole account, and they are said with weight. And it has to be said as plainly as possible, because the temptation to fill this silence is enormous, and it comes dressed as wisdom. No one knows the answer, not the physicist who has chosen an interpretation and learned to stop questioning it, not the teacher who is certain the traditions had it solved all along, not the materialist who is sure there is nothing here but mathematics, and not the seeker who is sure there is everything here but mathematics. The honest position is the same from every direction, and it is the hardest one to sell, because there is nothing to sell. We do not know. Anyone who tells you with confidence what the deepest layer of reality is doing, anyone who has closed this question, is telling you about themselves, not about the world. This is the discipline the whole long account has been built to protect, and it is worth one more breath. It would be so easy, here at the end, to tip the balance, to let the physics lean toward the mystical, or the mystical fold back into the physics, and send the listener off with a verdict that felt like an arrival. Almost every telling of this story does exactly that, in one direction or the other, because a verdict is satisfying and an open question is not. But the verdict would be a small lie, and the small lies are the ones that corrode. So the balance is left where the evidence leaves it, even and unforced and open. Here the careful skeptic deserves a hearing, because the skeptic is mostly right, and the honesty of all of this depends on granting it. A resemblance of shape, the skeptic would say, is not an identity of claim. The mind that finds the same pattern in physics and in old contemplative texts is the same mind that finds faces in clouds and stories in the stars. A pattern-finding machine that cannot always tell a real structure from a flattering coincidence. Physics needs no help from mysticism and is not confirmed by it. The equations stand entirely on their own, and dressing them in the robes of ancient traditions adds nothing to their truth and risks a great deal of confusion. All of this is correct. None of it is being denied. The convergence is being held at exactly the weight the skeptic would allow it, as a curiosity worth noticing, not a proof of anything. And the contemplative deserves a hearing, too, from the other side. Because a strict inheritor of these traditions might say something the spiritual marketplace never does, that the traditions were never trying to describe the physical world at all. Nagarjuna was not doing cosmology. The point of the analysis was never to anticipate a result about photons. It was liberation, the loosening of the grip of a self that was suffering because it took itself to be a separate, independent thing. To read these teachings as proto-physics, the strict contemplative would say, is to miss their entire purpose, to turn a medicine into a museum piece. And this, too, is correct. The convergence, real as it is beside the actual point of the people who found the contemplative half of it. So the open ground is not a comfortable middle. It is the refusal to collapse into either the dismissal or the appropriation. The skeptic is right that the parallel proves no doctrine. The contemplative is right that the doctrine was never about the parallel. And the strange fact remains, standing between them, refusing to be claimed by either. Two ways of looking, sharing nothing, kept meeting the same shape. The honest place to stand is in the middle of that, holding all of it, resolving none of it. That is not weakness. It is the only position that does not lie. And there is a freedom in it that the comfortable conclusions never offer. When you are not required to have decided, when the honest thing is to hold the question open, a particular pressure lifts. You do not have to defend a worldview. You do not have to have chosen, before tonight, between a universe of dead mechanism and a universe of hidden meaning. You are allowed to stand exactly where the evidence leaves you, which is at the edge, looking out, with the matter genuinely unsettled. That is not a lesser place than certainty. In this case, it is the more truthful place and the more spacious one, and there is room in it to rest that the certainties never had, and you have stood there, not in a laboratory and not in a monastery, in the ordinary places where the question arrives without being summoned. You have felt it. A coincidence so precise it seemed for a moment that the world was not as loosely joined as you assumed. The sense, looking at someone you have loved for a long time, that the boundary between you is real and is also not the whole story. The strange noticing that sometimes comes in a quiet room at night, that the separateness of things is the surface of something you cannot name. These moments do not prove anything. They are not evidence, and the careful part of you is right not to build a cathedral on them. But they are not nothing either, and the account that explains them entirely away has always felt slightly too small for the thing it was explaining. It is worth being careful here too, because this is exactly the place where the comfortable lie is most tempting, and you deserve better than the lie. The feeling does not make it true. The sense of connection you have felt is not a measurement, and it cannot be promoted into one. A person can feel deeply bound to the whole of things and be mistaken, and the history of the species is full of beautiful certainties that were wrong. So the recognition offered here is not that your intuition was secretly correct all along. It is something quieter and more durable than that. It is that the intuition was pointing at a real question, not a real answer, a real question. The same question the physics arrived at by its cold road and the contemplatives by their silent one. You were not confused to feel it. You were standing, without instruments and without doctrine, at the edge of the same open thing. You are a separate person. This is not an illusion. You are in a particular body, behind a particular pair of eyes, carrying a life no one else can carry, divided from everything else by a boundary that is completely real on the surface of things. None of the physics and none of the contemplation asks you to deny that. What they ask, each in its own language, is a quieter and harder question, whether that boundary goes all the way down, whether the separateness you live inside, real as the skin, is the final truth or only the surface of one. And the honest answer, after everything, is that no one knows, and that you live inside the question anyway, as everyone always has. The recognition is enough. It asks nothing of you. It does not require you to believe a single thing or to do a single thing. It is only a noticing, and the noticing can be set down as gently as it was picked up. There is an old image from one of the traditions that fits this exactly. Look for the self. The analysis went. Look for the separate, independent person at the center of your life, and you will not find it, not in the body, not in the thoughts, not in the sum of them, not in anything standing behind them. And yet here you are, real and unfindable, present, and not a separate thing in the way you always assumed. The person is real and is found nowhere, because the person was never the isolated, self-contained object the search was looking for. That is not a loss. Nothing has been taken from you. What is taken is only a belief about what you were, and what is left when the belief loosens is exactly what was always here, held in a web of relations it was never apart from. Think, one last time, of the two particles. They met once. They interacted, and then they parted, and they flew to opposite ends of whatever you can measure. And all the way apart, across all that distance, they remained, not in contact, not in conversation, nothing passing between them, simply not entirely two. The space between them is real. You could measure it. It was never the whole of what was true about them. It is the same with you, perhaps. That is the thing the long road keeps arriving at. From the cold side and from the quiet side, both. You move through your days as a single, bounded life, and that is not a mistake to be corrected, not a veil to be torn away. The boundary is real. You feel it every hour, and you are right to. The only question, the one the laboratory and the silence both walk toward by their different roads, is whether the boundary is the floor or the surface of something with no floor that anyone has found. And that question does not need to be answered for you to lie here inside it. People have lived their whole lives inside it without ever once naming it. It held them anyway. The separation is real. It is also not the deepest thing. And what the deepest thing is, no one can yet say, and perhaps no one ever will. And the not saying is not a wound. It is the open ground. It was always the ground. The certainty was the thing that was built on top of it, and the certainty has quietly come apart. And what is left underneath is older and wider and stranger than anything that was built. There is a kind of rest in standing here, not the rest of an answer, the rest of being done pretending to have one. The question is not a problem to be solved before you can put it down. It is the ground you are standing on, and it has been holding you the whole time, whether or not you knew its name. Two particles met once and parted, and were never again entirely two. And the distance between them, real as it is, has never been the whole of what is true.